It says that a particle of mass 7.5 kg starting from rest at A slides down an inclined plane AB. The point B is 12.5 meters vertically below the level of A as shown in the diagram. Given that the plane is smooth, use an energy method to find the speed of the particle at A. The first information that they've given us is that the plane is smooth. What that means is that there is no friction in this scenario in part A. Other than that, what we have to find is the speed of the particle B, and we have to use an energy method. So the energy method I always use is that the total work done by the driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against friction. So since there is no friction, this last component, the work done against friction, becomes zero. And since there is no driving force pulling the particle downwards, that means that the driving force must also be equal to zero, since the particle will move down due to its weight and not because there is force applied to it. So that means that 0 is equals to the change in kinetic energy plus the change in potential energy. So we know that the formula for change in kinetic energy is half times the mass multiplied by the final velocity squared minus the initial velocity squared. That means that this is half times the mass, which is 7.5. They have not given us the final speed, so this is v squared. And since it is starting from rest at A, initial velocity is 0, so we won't add that. And the change in potential energy has the formula of mgh, which is the mass, which is 7.5, and then the gravity, which is 10. So the change in height, now they've given us the change in height. So it starts from the top, which is h1, which is equals to 12.5. And then this is h2, where the height is equals to 0, making the change in height equals to negative 12.5. So a whole component is equal to negative 937.5, and half times 7.5 is, this becomes 3.75 v squared, meaning that v squared is, so when this goes to the other side, this becomes positive. So 937.5 divided by 3.75 is 250, making v squared is equals to 250, leaving v to be, which is the final velocity, be equal to under root 250. And if you want to be exact, that is equals to 15.81 meters per second. So that is part 1. So on to part number B. It is saying it is given instead that the plane is rough and the particle reaches B with the speed of 8. The plane is 25 meters long and the constant force has magnitude F newtons. So we need to find the value of F. So basically we need to find out friction, because now the plane is rough. And other than that, they have given us the information that the final speed, which I'll write as V, is 8. The initial speed remains 0 as total in part A, because they have not changed that. And now they're saying that this was the hill, as they mentioned, and this was A and this was B. So this side, which was the height of A above B, is 12.5. And now they're given us the length of the plane, which is this. So that means that the hypotenuse, you can say, is 25 meters. And other than that, we know that the mass is equals to 7.5. So in order to find the force of friction, which we don't know right now, we can use the method again. So that is the total work done by the driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against friction. So again, this total work done against driving force, it will be 0, since the particle is moving down because of its own weight. But the only difference is that now, since there is friction, we will have a work done against friction, and we know that is equal to the force of friction, which we have to find, multiplied by the distance traveled. So we have the distance traveled, which is 25 meters. So that means that this will become 25F. That means 0 is equals to half the mass, which is 7.5. The final speed is given to us as 8. So 8 squared, and the initial speed is 0, so you won't write that down. Plus mgh, which will become 7.5 times 10 times the change in height, which again is negative 12.5, plus 25F. So let's find out the value of this component. This is 0 is equals to 240 plus, this will become minus 937.5 plus 25F. 697.5 must be equal to 25 multiplied by the force of friction. And if you divide that, this makes the force of friction equal to 27.9.